All right, page 11 of the computer system notes, section 7, it's the last section, and we're going to talk about if I could spell, we're going to talk about the microcontroller unit, also called an MCU. And the MCU integrates your processor and pretty much everything else it needs onto one integrated circuit or chip. So it integrates processor, memory, and peripherals. So your peripherals are I/O devices, serial ports, USB hosts, and timers, and the real-time clock on one IC, integrated circuit, or chip. And I've never heard of an MCU that has a virtual memory. Some of them will have a cache, but a lot of them don't, so usually no cache. So fairly simple processors, and our example is the LPC1768, which is a chip that has an ARM Cortex M3 processor built into it, plus a bunch of other stuff. And I'm just going to switch to a different view to show it to you there. So I've downloaded this image from the Kyle website. I've got a page dedicated to the MCB 1700, which is the development board that we are using. And right in the middle there, where I circled it, is the LPC1768, the microcontroller unit. So it's got a ARM Cortex M3 processor in it. It's got the clocks, the I/O devices, and the picture quality is not great, but if you look around the edge of it, there's a bunch of tiny little pins that are soldered into the board, and those go to different things. So for example, on the left here, we have a couple of DC9 connectors. So probably, well, one of them's labeled CAN 1 and the other one is CAN 2. And on the other side of the board, same type of connector, but they are the UARTs, the serial port. So there's two of those. The large dark thing here is an LCD that you can draw to. There is an Ethernet port, top left there. There is a potentiometer here, a variable resistor. There's a little joystick here. You can push it in 4 directions or push straight down on it. And then there are 2 buttons, a reset button and just a user input button. So this is a development board, but at the heart of it, right in the middle, is the LPC1768 MCU. And through the traces on the printed circuit board, it's connected to all those devices. Okay, so back to the notes. Okay, so I'm going to just show you a simplified view of what's in the LPC1768. And I'm going to just start a little bit in from the edge here so that I can add some labels. So we've got the ARM Cortex M3. So the M3 processors, I believe that stands for mobile. They're low power. They're cheap processors, but they still do enough. So we've got that, and beside that we've got the Ethernet controller. And beside that, I'm going to draw the USB controller. It's usually called a USB host. And these all connect through something called a bridge. So think of it as a switchboard. So So here's the bridge, and it's just got a whole bunch of connections running through it. From the ARM, there are actually 3 different buses on the ARM processor's interface that connect to the bridge. And so this first one is the system bus for I/O, so for connecting to other peripherals through the bridge. There is what's called the decode bus, which is the data bus. So it reads and writes data from the SRAM through the decode bus, and then it's got the I-code bus, which is for fetching instructions from the flash or from the ROM. And the Ethernet will be connected to the bridge, as will the USB host. So over on the right here, I'm just going to draw our 3 memories. So we've got flash memory, we've got SRAM, and there is a ROM, which must come with some default code that it can run straight from the factory, but we don't use that. So each of these is connected to the bridge. And I'm showing single lines, but those are going to be multiple lines. So for example, the connection to the SRAM would probably have 32 or probably 32 address lines, 32 data lines, and some control signals, read and write, enable. That would be most of them for an SRAM. And going down from the bridge, there are 2 peripheral buses. Not sure how long to make them, so let's just make them extra long here. So this is peripheral bus. So ARM uses a standard bus called the APB for these, Advanced Peripheral Bus, and then the connections from the processor to the bridge are the AHB, the Advanced Host Bus. So they're industry standards that it uses. So let's just add a few I/O devices in here. So UART, if you have looked at Lab 0, you should be familiar with the term, stands for Universal Asynchronous Receiver Transmitter, and it's for, it connects to the serial port. So I showed you 2 of those serial ports on the development board, the MCB 1700. And I'm just going to give you a selection of different types of peripherals. So here we have a CAN controller. And so some of you, either through student teams or on co-ops, have probably been exposed to the controller area network, and you'll know that it's used primarily in automotives. And it's a 2-wire bus. Anyway, so it's interesting. I used to cover it in this course, but now Allison covers it in MTE241, so you'll learn about that next term. And a DAC is a digital to analog converter. I am forever calling it a digital to audio converter, which I guess is one use for it, but it's not what it stands for. And the LPC 1768 has, I believe it's 4 general purpose timers, timer 0, 1, 2, and 3. And in addition, I'll draw it over here, is the real-time clock, or the system clock, and that's used by the operating system to basically time or control how long each task runs for. So it'll interrupt the processor at a regular rate, and then the processor will run the scheduler and decide which task to run next. So working our way back up, the complement to a DAC is a ADC, analog to digital converter. I'm going to draw, okay. Another CAN controller, there's two of those. Let's draw another UART over here. So there's a selection of peripheral devices. So these peripheral devices, at least the I/O devices, connect to the outside world. And I'm just going to just add the names here. So UART is our serial port. So it'll be connected to one of those connectors that I showed you. Controller area network, I'm just going to write that it is an automotive network. And ADC is the analog to digital converter, and that's good enough. So these I/O devices will be connected to those pins that you could sort of see in that image of the LPC 17.